All right. Well, I'd like to thank you all for joining me today. My name is Sam Reve, and I'm an engineer here at Muk3D and operate within the North American region. So I just wanted to take some time today as we're getting ready to roll out the next iteration, version 2025 of the software for both Tailings Plus, Formation, and Simulation, to just take some time and really focus on formation. I know it does sound cheesy, but I do think it is the best kept secret in terms of engineering software out there. It is, for lack of a better word, the base version of the software. It doesn't have those tailings deposition tools, but it does have a lot of those great structure modeling tools. It's really streamlined and very powerful. And I think it's also very attainable. The modeling I'm going to show you today in terms of the formation tools, they're distributed on a per user license, and it's going to vary by region, but it's roughly $500 American per license per year. So a very powerful software and very attainable. So I just want to go over some of the overall changes with this next version in terms of Muck generally, and then focus on some of the advancements within Formation itself. Okay, so I'm going to start here just in terms of the executable file, the installation process, the licensing process. It's really been streamlined. If you're a Muck user of either Tailings Plus or Formation in the past, you'll know you have to install CodeMeter, Catapult. You're executing Muk3D from Catapult. And that process isn't the worst thing in the world, but also isn't necessarily as straightforward as it could be. Now, when you get this new version of Muck, you just install one software, Muk3D itself, and you launch it from this one executable file. In terms of licensing, specifically for Formation, you're not going to have to go through Catapult anymore. You're just going to add your license for Formation through a user locked license. You'll have a password associated to your email, and then you can just launch it from there. So just a streamlined process in that regard. Okay, so I'm just going to launch Muk3D right now, version 2025. As this is loading, I'll mention that the software has now been updated to Python 3.13, and that's going to allow for the installation of third-party packages that you can incorporate into the software. Okay, so to begin, one thing you'll notice with this new version of the software is a little bit of a different layout, but still very similar to the old one. If you're a user of the previous version, you'll have no issues, using this. It's very straightforward. There are updated file types though. So for example, here I have a .polyline file. In the past, this was a M curve. You still have the ability to save any layer in this upcoming version in the old file types. However, the new file types won't load in the 2023 version. So if you're working in 2023, you want to migrate files over, those will work just fine. But you can't load, the new version into 2023. But if you have 2025, why go back? Same thing for grids. It's now a grid instead of an mgrid file, and that's obviously transferable. As well, all of the styles, the properties are now embedded in the item itself, so there's no longer the need for those mdrawable files. I'll just bring up version 2023 here so you can see what I mean. When you'd save a layer in the previous version, you'd have the layer itself, the file itself, and then an mdrawable file that holds its style properties. That's all been streamlined into one file type now. You'll notice if I select a layer now, a new feature is this properties window here, just giving you a lot of information so you don't have to go through the info menu. You can see here for this particular piece of topography, I get the grid spacing, the size, the quad count, the point count, and that's true of any layer. The information will be immediately listed. There's also more information in the database viewer here in terms of your viewpoints, your zonation models, your colors, your textures, and those can be applied directly from the database viewer onto your layers. So if I want to make this red, I can just now drag and drop it on. Maybe you want to apply a specific type of texture to it, or some level of elevation map shading. So more, just a little faster, a little smoother, more information at your fingertips so you can work a little faster. There's more functionality in terms of the software picking up on the coordinate reference system of files. So for example, here I have a TIFF, a DM of some topography. I'm just going to drag and drop that in. And you can see here, if I expand this a little bit, it's immediately picking up on the native coordinate system of this file. I can immediately have the option to thin this data so I don't have to import, all 3.9 million points. If I want to thin that down a little bit and just get that down to 442,000 points, that's an option. I can also reproject it from, this coordinate system to the coordinate system that I'm working in. I'll just bring this in quickly. So you can see that loaded very fast. In regards to the coordinate system, it's now a little more dynamic. There's a button down on the left-hand side. You just click that, and then you can set it to whatever you'd like. I want to go 13 north instead of 12 north for whatever reason. Just look that up. So it's more dynamic. You can change it as the project goes along, and really make sure that you're aligning what information you have with, where you're working in space within the software. So when you export this data and, someone wants to stake it in the field or survey it or, locate a line, in real life, there's alignment there and everything will be accurate. Okay, in regards to just general processing speed, it's probably one of the bigger advancements here. And I just want to display that for you now. Okay, so I have a 2-meter grid here, 2-meter LiDAR grid. Fairly robust surface, a lot of points. I'm going to import that in. If I take a look at its properties here, we're dealing with 2.25 million points. So, not the largest surface in the world, but not insignificant. And it loaded very fast. And just for reference here, I'm going to bring in version 2023. I've taken that same grid. I've saved it as an M grid. It's the same size. And I'm just going to import that into the older version. So it's just the point I'm trying to make, it's not importing. So, and you can see it just closed. So there's been a huge upgrade in terms of just the scale, the size of the data sets that this version of the software can handle versus the previous version. So you can work with those, denser LiDAR grids. We went up to 2.25 million points here, probably could have gone up to 5 million, 6 million. Obviously, I advise that you don't overdo it in terms of the size of the files that you work with. A lot of the time that's not practical or useful, but it's something that has taken, I think, a giant step forward in this version. Another functional upgrade is just, it seems like something that's pretty small, but I think it's fairly significant on a day-to-day basis. It's just the draw line function here. So I'm just going to draw a line. I'm going to start out at an elevation of 1,600 meters. I'll put the elevation guide on here so we can see what is above and below 1,600 meters in elevation. You'll notice immediately as I'm drawing the line, there's a lot more information here in the property menu, just in terms of the configuration of that line, the node spacing. So I'm just going to place a point here, place a point here. You'll notice it's giving me the coordinates. It's giving me the distance between the nodes that I'm placing. the cumulative distance, the slopes. But also here, I now have the option to, if I don't want to be consistently at 1600 meters, I can go into OSNAP mode, which will then place points on my surface here. So now instead of placing points consistently at 1600 meters, I'm just going to, place a point at the elevation of where my cursor is relative to that grid. But I don't have to operate in plan view exclusively anymore. I have the option to tilt the surface as I'm drawing and place a point in an isometric view. So it's giving you more flexibility in terms of drawing lines and also more information as you draw that line. If you want to monitor, for instance, the slope from point to point for, a pipeline layout or a distance, have that option in the software. It's just a handy thing. And this is all included within Formation and Tailings Plus, of course. It's not the prettiest line, but I still have a lot of flexibility in how I drew it. I don't think I need that. I'll just close that down. Another significant upgrade is the speed of the processing for the watershed tools. So if you're trying to determine a stream network, catchment areas, for topographic surface, it used to take probably, 10, 5, 10, 20 minutes to take that topographic surface and process it into a flow grid where you could then determine, where your streams were going to flow, what the catchment areas were going to be. Now it's done in seconds. I'll just go here and pick the lighter surface that I'm viewing in my 3D window. I'll hit OK. You can see you've generated the stream network immediately. I can then come here. Select a stream. And determine the watershed. Okay. What I really wanted to focus on is really the strength of the software is the dynamic modeling tools. Let's bring my grid back in and just discuss, the different types of structures you can build, the advancements in the dynamic modeling, and, how streamlined and fast it is. Especially if you're trying to get rough estimates for volumes, design a structure quickly, develop a tow line, develop, footprint areas. I really think this is second to none. Okay, so I'm going to start with a dam. So I'm just going to quickly draw a dam. I'm going to set my crest elevation at 1600 meters, do a crest width at 20 meters, 4-to-1 left slope, 2-to-1 right slope. Depending on how you draw the line, those will be downstream or upstream. And then just an unclipped shell height of 150 meters on either side. And I'm going to choose to merge it into the grid, which is going to create a dynamic model. So you can see once again in the property window, it's giving me information to the on the center line that I'm drawing, and the dam shell is generating as I'm digitizing the line. Okay, so you can see here I created a dam structure. I'll just take a look at these layers quickly that it's created. So it created the center line that we drew. And the dam shell. The break lines associated with that dam shell, crest, toe, the upstream crest, the footprint of where that dam shell intersected topography, and probably most importantly, a merge grid. So it took that structure, merged it into the surface, and clipped it. If I select this root item here, in the property window now, I now have my dynamic model that I can manipulate. So for example, I drew it, I guess, clockwise or counterclockwise. So my upstream toe is where I want my downstream toe to be. So immediately I'm just going to reverse that so that this 4-to-1 slope is now on the downstream side, 2-to-1 on the upstream side. And you can manipulate your design now in a lot of different ways. You can manipulate your inputs to modify your outputs. And you can also goal seek specific inputs to hit targets for your outputs. I'll just display that quickly here. Okay, so, let's say I want this to be 6-to-1 instead of 4-to-1. You can change that and it'll update your volume. I can change the downstream slope. You can change your upstream slope. So you can make those kind of changes. Also, you can manipulate the crest line and update your surface as you go. I'm just going to edit this line. I'm going to select it here, move it around. And you can see there, it's going to regenerate the dam and also update that fill volume, that footprint area, and the associated line work. Everything's dynamic. Let's say you don't want to be in line elevation mode. You have a variable elevation crest. It's not at 1600 and you want to offset it up and down. You can go to either user elevation mode and put in, new absolute elevations for your dam crest, or go to relative offset, and then you can increase it whatever you'd like on a relative basis, which would be useful if you don't have a consistent elevation there. I like line elevation mode because it allows me to manipulate the the line work itself and regenerate the design. Okay, so now you're in a situation where maybe you have a specific volume target that you want to hit, and you have some flexibility in terms of your slopes or your crest width. You'd have the option of going here and optimizing your design. Okay, so I'm at 63 million cubes roughly. Let's say I want to be I want to be at 55 million cubes. That's all of the material that I have. I'm going to optimize the volume. And to do that, I want to take some material off my left slope or my downstream slope. So that's the parameter to change. And I have to enter a guess. You can always guess what it currently is. 4-to-1. Hit OK. You can see here, within the error tolerance, I'm now at essentially 55 million cubes of fill, and that required a 3.209 left slope. You can also make changes to the line work not only in plan view by manipulating the line itself. You can do it in section view as well if you have more granular changes that you want to make. So if I come here and I go to edit line profile, I like to select the center line and then the original ground surface. I've selected the center line and the original ground surface. So you can see the green line here is the center line of the dam. And this is the original ground surface below the center line, obviously. So you can manipulate your center line in section as well. So let's say I want this entire crest to go up at 1%, as opposed to just being at a consistent elevation. I can modify it that way. Come here, update my 3D alignment. You can see I went from 64 million cubes to 105 million cubes. And, it's now going up. Now my unclipped shell is no longer long enough to project the slope down. So I can come here and I can increase that on both the upstream and downstream side. And once again, that's going to add volume as well, because I'm not going down a 1 to 0. You can move points up and down. You can add points if you'd like on the line. You can select a point and set its elevation. So if you have more granular changes, maybe you want to add a slope, this is a very useful tool to apply. Let's say if you're designing a road as well, and you want to balance the cut fill quickly, you can come here, make those changes, check your slopes, update your volumes to see if you're balanced in cut and fill. So a lot of different ways to manipulate surfaces, shells, designs quickly to reach specific volume targets, specific footprint targets. I'm going to close this one down. I'm going to just regenerate it again. But this time I'm going to add a pond. Close down layers I don't need. So I'm at 1,600 meters in elevation. I'm just going to come here quickly, add a pond at 1,580. And kind of display how the dynamic models also work in tandem. So once again, the pond is dynamic as well. I can see the fill volume here, or the storage volume or pond volume of 46.8 million cubes. If I come here again and I, start manipulating my crest line, and I'm going to go from 46 million cubes to 55 million. And I can also optimize my dam design as well to meet pond targets. So right now I have, let's say, a upstream slope, which I believe is the right slope. Let's test that out. A 4-to-1. Was that let's see that again. 4-to-1. Okay, so my left slope is my upstream slope of 3-to-1. Let's say I want to add some capacity here for the pond. I'm at 55 million cubes, 3-to-1 upstream slope. I'm going to optimize this to 60 million cubes. I've already forgotten which slope it was. Okay, it's the left slope. Optimize my volume, going up to 60 million cubes. And I'm going to target my left slope, which is currently 3-to-1, which is also going to be my guess. Let it run for a second. All right, so you can see I achieved 60 million cubes of pond volume, and that modified the upstream slope from 3-to-1 to 2.436. So double dynamic models now working in tandem. So you can manipulate different design criteria quickly to get where you need to go. All right, let's try another dam example here quickly, because they're my favorite structure. This time I'm going to do a bench dam. So I'm going to create a bench dam from the center line. I'll have a crest width of 25 meters, right slope of 2-to-1, 100-meter unclipped shell height, 2-to-1 upstream slope, 10-meter bench height, 10-meter bench width, and unclipped shell again of 100 meters. I'm going to merge it into the grid and reverse it. I'm going to select my grid, select my line. Once again, now you can see the beautifully textured dam shell. And more importantly, the merge grid with the footprint and all the line work that's created and is dynamic. So as we change the design, all the line work will update as well. Same options here. You can manipulate the center line, change your dam structure, And once again, you can optimize your design here. So, I have 101 million cubes of fill. Um, let's say I want to bring that up. I can change that volume, or let's say I want to increase the footprint area. I want to target a value of, 2.5 million. And to do that, I'm going to increase that bench width. Right now it's 10. I'm going to guess 10. Hit OK. And you can see here, to achieve that footprint area, I need a bench width of 18.4. I want to reduce now the volume of fill. You can do that by just optimizing the bench height. Play around with different designs quickly and achieve those results instead of, that's offsetting polylines, retriangulating a shell, running the volume, see if it works, doing it again and again and again. You can get there very quickly. And I think the fact that the, line work, especially for a structure like this that contains a lot of line work, the fact that it's dynamic and it'll kind of change as you go is very practical. So let's take a look at a different type of structure. Let's take a look at an excavation. Same concept here. I just have a rectangle that I've drawn pretty close to my topography. I'm just going to excavate down and create a sump, if you will. And just quickly, you can see here all the dynamic models that really follow the same template as the dam structures and the excavation structures that we're looking at right now that you can use, whether that be ditches, roads, graded pads, dumps, ponds, everything's dynamic. Okay, so I'm just going to excavate from the crest. I'm going to go down at 2:1 to start and excavate down by the shell height, which will be 20 meters. We're going to go down at 2:1 for 20 meters and create a dynamic model by merging it into the grid. I'm going to select my grid, select my crest line, and once again, take a look at these layers. So it's created the shell itself, break lines of that shell, the toe, so the base of the shell, the grid with the excavation merged in, and the footprint. Once again, this is dynamic. It's giving me my excavation volume, the footprint area, and the maximum depth that I've achieved. And you can come here. No, I want to go down at 3:1 instead of 2:1. Maybe I want to go down at 1:1. But I want to go down for 30 meters. You can see here I'm dynamically updating the excavation volume, the footprint area. Again, if I manipulate that crest line, it'll update my design immediately, update the volume, the footprint. Okay, so I have an excavation here. I've gone down consistently at 30 meters, but I'm not exactly sure, what my capacity is. I can check that quickly using the water tools. Water, find maximum containment elevation. And this is going to create the maximum amount of pond, the maximum storage pond, and tell me what my elevation, my max contain elevation is. Just thinking for a second. Okay, so now I know in this area, my maximum containment elevation is, 15.081. It's going to give me a pond surface area of roughly 69,000 square meters, and I can store 1.325 million cubes in there. All right, so that's good information. So now I'm going to create a pond at 1515. just below my max. In my sump, and then kind of work with those pair dynamic models again. All right, so I go back to my excavation, going down at 1 to 0. I'm going down 30 meters, and that's giving me a storage capacity of, 1.319 million. So now I'm gonna want to hit more pond volume. Um, I want to bump that up to 1.45 million. And to do that, I want to excavate deeper. So I'm gonna change the shell height, which is, in this case, the depth I'm excavating. I think it's currently 30, so I'm going to guess 30 and hit OK. All right, so it achieved it within that error tolerance, which you can play with. You don't get that as tight as you'd like. And I can see here, to achieve that extra volume, I had to dig down 2.88 meters deeper. And then it updates, obviously, the excavation volume as well. So once again, I'm doing a lot of work very quickly here in terms of determining volume metrics, making design shells. When I started, that would have taken me, using other software, that would have taken me a lot longer. Okay, one more dynamic structure, and then we can move on to taking a look at how you can pair formation with simulation modeling and really supercharge the speed of your engineering. All right, and I close everything down other than my original grid. And just quickly take a look at a dump structure. All right, so I have a circle here. I'm just going to go here and generate a dump structure, a bench dump structure from this crest circle. A 2 to 1 for the slopes, bench height, bench width 5 meters, and a shell height of 75 meters. And once again, merging it into the grid to create that dynamic model. Select my grid, select my crest line. Take a look once again at the new layers that have been created. The shell, unclip shell, auto applies this rock texture for the dumps. Break lines associated with that shell, the toe of the structure, the footprint, and the merge grid itself. All right, so once again, you can optimize here. So if you have a bench dump, you quickly want to size it for volume, and come here and optimize this. I'm at 30 million cubes. No, I want to be at 40 million cubes. And to do that, I'm going to change my bench width. It's currently 5, so I'll guess 5. Okay, so fairly significant increase in my bench width to achieve that volume. I need 18.1 meters, and you can see that updated right there. Conversely, I want to reduce this footprint area now. It's at 1.25. I want it to be at 1 million. And to do that, I'll change the bench height, which is currently at 5. So I'll guess 5. You can see here, this is where you'd set your error tolerance, currently set to 1. I can bring that lower if I'd like. I just can't make it exactly 0 because then it's going to look for, an exact number with infinite decimal places. So there needs to be some level of tolerance, but it could be 0.1%. Just have the ability to sequence dump construction. Yes, we will take a look at probably something in that vein very shortly, which is the question from the chat. Okay, so once again, it goal seeked a bench height of 7.9 meters from 5 meters to achieve that reduction in footprint area. So, I have a fairly intricate structure, not overly complex, but still a lot of benching here. And I just goal seek 2 different parameters fairly quickly. to achieve a design that I want. All right, let's move on to a dump simulation. Just going to change my project directory quickly. I don't think I need to save anything. All right, so this is a simulation model that we're pairing with Muk3D Formation. So we're going to leverage those structure building tools and wrap that in a Python script that's going to tie into a spreadsheet. So really, we're going to be operating Muk3D Formation from an Excel spreadsheet through Python coding, and the interface here is called Muk3D Simulation. So Muk3D Simulation is an add-on package. So it's not $500 a license like Formation, but everything I just showed you is all based in Formation and is, 500 US pretty much per year for a user license. And I think you could see that, if you have Earthworks projects, you can do a significant amount of work quickly, especially if you're using less tailored software that's, probably you could probably still get there, but it's more convoluted and, not as streamlined, let's say. But this is Muk3D Simulation. This is where you build 3D models and operate the software from Excel. So for this particular simulation model, we're allocating material to a celled dump. So a dump with many cells. And then we're going to allocate volume very quickly over multiple periods. Okay, so I'll just kind of set this up quickly. So this is the original piece of topography. It was publicly available data. It's actually an active TSF. Right, so this was an inactive TSF. As I'm kind of displaying this project here, I'll just go over another feature. If you're in the right coordinate system, you can leverage publicly available satellite imagery and bring that into the software immediately. I'll just do that now. Just going to go to imagery here, import, actually download TMS tile for geometry. So I want to bring in satellite imagery that's publicly available, but still fairly high quality for this piece of topography. I'm going to go with 16 zoom level, and I'm going to go with my favorite publicly available satellite data, Google Maps satellite. I'm going to hit OK. And that's just going to go find a piece of imagery that has the same location as this, that's publicly available, and bring it in. You can see it draped it on the surface. And because there's alignment, because I'm in the right coordinate system, everything is nice. Okay, so I wanted to find something publicly available with a lot of cells. This looked pretty good. TSF might, be similar to something that a current operation is working on. I'll just go back to white here. I guess now the image is draped. Okay, so one thing I guess here was when I looked at the actual topography that was publicly available, there weren't that many cells in the actual LiDAR topography versus the imagery. So I modified it a little to get the base surface that I'm going to be using here in this example. So you can see here I added some cells. Just some cell walls using that drawdown function. Just quickly added a bunch of cell walls. And if we want to take a look at it more specifically, I'm just going to quickly make a cut fill map here. Also displaying how easy it is to make a cut fill map. Grid, create an isochord between two grids. I do want height. I'm going to go with my upper grid is the one with the cells, walls, and my lower grid is the one without. You can see here, I just created a cut fill map. My color scheme is customizable. This is the default one, but I guess the point I'm trying to make is that was very fast. Okay. So if I take a look, once again, I'm just going to discard this, bring in my cells here. This is the layout here that I'm looking at in terms of my TSF. So I took that TSF and just divvied it up into 26 different cells. And what we're going to do is we're going to have a production schedule of the total amount of waste rock in per day, the number of days. That's going to give us the total waste that we want to allocate. And then on a percent basis, I'm just going to take that total and allocate it to different cells. And that's going to read the elevation of each cell over time as I allocate more volume to it. So in this case, my input here is volume per cell, and the output's going to be the elevation in that cell. That's going to allow me to quickly plan, the elevation of all these different cells over a period of time. And I'm not going to have to do anything in Muk3D other than really run this simulation. And then I'll have the ability to just change my percentages and see what happens with the elevation over time. So if I go here, you can see I have all my cell boundaries. And I have here a final design that I'm building towards. So that's really what I need here to run this simulation. I need a final design to refer against because I'm building towards this final design as I'm allocating material. And then I need to tell it, where the cells are located by having some line work for these 26 different cells. And the Muk or the formation tool that it's really leveraging is this tool here. This grid merge dam using boundary and elevation constraint. So I'll just run it once for you here. I'll pick cell 18 as my example. Okay, so if we take a look at cell 18 here, it's just this one located over here. Kind of looks like a giant swimming pool. Okay, so I'm going to run this quickly. Grid, merge dam using boundary and elevation constraint. So I'm going to say build cell 18 up to 20 meters in elevation. Here I have a default setting of 2-to-1 slope. You can change that. I'm gonna leave it. I think that's pretty realistic, 2-to-1. I'm gonna hit OK. I'm gonna select my base grid here with my cell walls built in. I'm gonna select my final design that I'm building towards and my boundary, which is cell 18. And it's gonna create a new grid here with cell 18 built up to 20 meters in elevation. You can't really tell in plan view, so I'll just quickly make a cross section here while also displaying how easy it is to make a fast cross section. Just make a cross section through cell 18. And so you can see that here. This, you just make this bigger. Change the vertical exaggeration a little from 1-to-1 to 3-to-1. So you can see here I had my base surface in blue. Now I've built up cell 18 to 20 meters in elevation. And this was my final design here in orange. So I can add volume within here and it's just going to build up until it reaches that final design. Okay, but what if I want to do, 26 at a time? Clear my screen here. I go to my simulation folder. Just take a look at my spreadsheet again before I run it. Okay, so I've pre-allocated some percentages, so they add up to 100%. In the first period, it's going to take a little longer because I'm allocating volume to every single cell. Then it's gonna speed up a little. I'm just going to run 6 periods here, and then quickly add a period to show the flexibility in terms of you don't always have to run it from the start. You can run it from whatever period you like. And then that's going to output the elevation readings. As well, for every period, it's going to produce a cut fill map showing the vertical change from the previous period. So I'm just going to run this. This might take, a couple minutes to run. but I think you get a good realistic idea of, how long this would take to process. So you can see here, it's going to go through every cell. It's going to allocate that volume until it reaches an elevation. It's going to pull out that elevation reading and then send it back to the spreadsheet. So simulation is, more typically associated with Tailings Plus because people do want to build these simulation models of their TSFs and, take advantage of those deposition tools. And you can really do a lot. I think you can really capture all of the complexity, of a tailings storage facility with simulation. But it's also very useful, with just the formation structure building tools, especially if you're in situations where you're spending a lot of time allocating volume or um, building a lot of structures. And we'll take a look at another model after this. And this isn't instantaneous, but if I had to do this manually, how long are you spending doing this type of thing? And this is a fairly simplistic model. It's really just using that one, you know, merge merge tool with a elevation constraint and a polyline constraint, and then producing a cut fill map. So it's just really tying two tools together and linking it to a spreadsheet. But you can link as many tools as you want together. Also, if you have a simulation license, you can build as many of these models as you want, and everybody can use it. Okay, so I'm at dump 20. 21, 22. I'll stop counting. And you can see here in the output window, it's goal seeking the appropriate elevation until it reaches that error tolerance it's comfortable with. And now it's just creating that first period grid with now all that volume allocated to it and merged into the different cells. Once that's complete, it's going to create the visual, the period map, and then output this, update the spreadsheet. As well as it's doing this, so that's the cut fill map. It's going to save it as a JPEG in that working directory. And then it's moving to period 2. If I take a look at the spreadsheet now, I can see I have elevations for this first period. Sorry, yeah, I have elevations for this first period. It's just all these are populated because it's just reading that first period, and then it's taking that value until it up to the second one. But you can see here, it's read the various elevations throughout the TSF along those cells. And if I come here and I explore this folder, I can see here that first period cut fill map. So it's just going to run through every month, allocate the volume, update the elevations of the cells, and produce a visual. This might be a little redundant, but I'm going to let it run for these 6 periods, and then add an extra period at the end and rerun it for that additional month, just to kind of go over the workflow. Okay, so let's finish period 2. It's going to go a little faster now because I'm not allocating to all 26 cells. I'm probably allocating to 5 to 10 per period. And now we're in period 3. You can see updates to cells where there's been volume allocated. So you can see cell 18 went from 18.32 meters in elevation to 21.57. Cell 10 went from 30.55 meters in elevation to 43, so on and so forth. I think we're almost done period 3. New cut fill map, saved into the working directory, moved on to period 4. So just do 4, 5, 6, then I'll add 7, and then take a look at another simulation model. And I don't have to do anything in the software. I can just operate it out of Excel. So whatever workflow you have, you know, however many functions you might be sequencing over a long period of time, you can chain those together, wrap that into a script, and add that temporal component to your work through Excel, and then just run it from there. Run a lot of scenarios quickly. Obviously, you can get to a point where you can build these simulation models yourself, especially some of these more straightforward formation ones. We can provide training to that extent, or we can just build them for you. And depending on the complexity, it really shouldn't be that much work for us. So once again, just creating that merge grid, the visual, cut fill map, save it, move on to period 5. So always referring back to that final design, same line work, just progressively building up each cell as you allocate volume to it. Maybe I should have done 4 periods instead of 6. You guys probably get the idea by now. Other cut fill map. And finally, it's going to go to 6, and then we'll stop because there are no more periods allocated after that. If we come back here and we look at our cut fill maps, we can now see that we have one for multiple periods. And this is all customizable. You can, play around with the color scheme, the vertical iterations. Now, adding a period is very simple. I can come here, I'm gonna add another month. I'll just carry this production over, carry these allocations over. Just move that coding around. And then once it's done the 6th month, to show you how to run it from, for just that additional period. All right. Well, I guess I added it as it was working. So you can see here, it's just gonna run that 7th period. But you can just, if it would stop at the 6th period, you can just go in here, use your simulation function, Excel, run that Excel model and just say, run it from the 7th period, and then I'll just run that extra month. So let's say you're in a situation where, the first, 8 periods that you've run are good, but after that 8th period, you want to restart and make some changes. You don't have to rerun the model from the beginning. You can always rerun it from whatever period you want, and then just keep going. Okay, so once this is done running, I'll just switch to a site selection simulation model, leveraging, a couple different formation structure building tools. Okay, so it's completed. I'm going to open another project here. And this is a design option simulation model. Okay, so for this one, we'll just set it up a little. I'll try to make this quick since I've gone over time, of course. Okay, so we have a piece of topography here. And we have 3 different sites, right? So I don't know if I want to build my dam here, here, or here. And I have some evaluation criteria, and I'm still a little uncertain as to, what my slopes should be, maybe my crest width should be, or my elevation on my crest. So this is going to be managed from this spreadsheet here. And here you can enter in, which site you want to take a look at, which is basically which center line of the dam. You can set your crest elevation, the freeboard. So where do you want to consider that pond to be versus that top of dam crest? You can set your crest width and your upstream slopes on your dam. And this is going to output the fill volume you need to build that scenario. The water volume you can store based on where your pond's going to be, your maximum containment elevation. So it's just going to check, even though you're saying your crest is at 1,300 meters in elevation, is that actually your maximum containment elevation? Because I can build a crest up to, 18,000, but if I have topography in that area that's below that, that's where the water will flow. And then it's also going to calculate that pond area based on that freeboard and your crest elevation. And then it's going to, take those values and take that storage volume and divide it by the required fill. That's going to be criteria 1. And then criteria 2 is going to be storage volume divided by pond area. So it'll allow you to quickly assess. You can see here a number of different options by just running the model and not having to do all this CAD work manually. So I'll just run this quickly. And this is really just leveraging that create a dam from centerline tool, create a pond that we took a look at when we were doing some dynamic modeling, and find maximum containment elevation. So just chaining those 3 functions together, pulling out the volumes, the areas when those functions are running, and then throwing that data back to Excel. Okay, my graphics, and I'm just going to run this. So you can see here, it's moving that crest to the required elevation for the required location, building that pond, and then it's going to start populating these values into the spreadsheet. It's checking to see what the maximum containment elevation actually is, and it's pulling those values out. You can see here, put into your spreadsheet, did the math that you asked it to do, and then put it in a chart. Criteria 1 being the gray bar here, criteria 2 being the orange bar, and it's just going to sequence through all these options. Just let it run for a second and watch as this updates. Okay, so it's moved on to site number 2 here. Once again, put in all that information to Excel. So I've just evaluated 3 different options and it took seconds. So I'm just going to let this run for a bit. Then I'm going to show you how easy it is to add, another alignment and evaluate another option. So you can see for every option, the fill volume to build that structure, the pond capacity, the actual containment elevation, which in these cases does match the crest elevation, and the pond area. And then, you can get Excel to do a lot of the lifting in terms of your outputs. It's really, you want to take advantage of the 3D modeling within the software, which is, I think, unique and automatable. And then, get Excel to really move the numbers around in the way that you want. All right, so I just evaluated these options. It's complete. Okay, so let's say I want to add another one quick. I'm going to come here, add a period. This time I'm going to site 4. I'm going to go, 1414 in elevation, 2 meters of freeboard, 50-meter wide crest, and some 3-to-1 slopes. And really all you have to do in the software is just create a center line with the X and Y where you want it. Just point it to a pond location here. So I just created, a center line in X and Y at the location that I'm considering. Created a point here for where the pond would be. And then I can just run it for that last period. I'm going to pick my model. I'm going to say started at period 9. My starting directory is going to be my base folder. And my resource directory is going to be where my data is. And I hit OK. Then it's just going to do that last option. It did not like that. Centerline.polyline doesn't exist. Maybe I need a centerline 4 here. Save this as centerline 4. No, this should work. One second. Live troubleshooting, always fun. That's my base grid. 1, 2, 3. Okay, so what happened there was I had 2 spreadsheets open, and it tried to read information from my dump staging spreadsheet from the previous model, as opposed to my dam siting spreadsheet. And so I just had to pick the appropriate spreadsheet. All right, then I can just update my graph here, include that extra information, and then visualize this last option versus the other ones. And that's this model. Okay, so that concludes the content I wanted to cover today. I know there's a little bit of time left. I will post this video, put it online. Do you guys have any questions before we part ways for today? Yeah, so everything I just showed you was formation, but formation plus simulation. All right, so I guess I probably haven't made it clear. So Muk3D is the suite of softwares. So there's a number of, or there's essentially 3 softwares that Muk3D produces. So Muk3D Formation, Muk3D Tailings Plus, and Muk3D Simulation. So Muk3D Formation is, I guess you could call it the base version of the software. It has, all the Earthworks tools, the structure building tools, everything I showed you today is present information in terms of the tools. And that is, $500 US for an individual license. Now, these two models leveraged Muk3D Simulation, which is an add-on package. So it's an add-on package that allows you to, incorporate or tie Excel directly into the software, Excel or GoldSim. So you can operate the software from, a spreadsheet. And so it's going to read input values, and then it's going to output, the results of the 3D modeling. So, and it allows you to really automate your work and add, I think, most importantly, kind of a temporal component. So you can start to work with schedules as opposed to doing one period and then doing it manually the next. You can do these over time. Now, a lot of people like to take simulation and add it to Tailings Plus and really leverage, the tailings deposition tools and, take a production schedule that you would get from the plant, or whoever's upstream from you in terms of your work, take those tailings volumes, those pond volumes that they're telling you per period, all that information where your deposition points are going to be, build a full 3D simulation model of it, and then, run different scenarios very quickly. And that is probably the main use of simulation. However, you can see that you can leverage the tools within Formation pretty easily with simulation as well, and really streamline this process. So this is, Muk3D Formation plus the simulation add-on. Now, simulation is I think it's 7,100 US, roughly, a license. But you can build as many simulation models as you want. You're really just chaining together a couple of different tools and then tying it into a spreadsheet. And you can chain in as many tools as you want and create really a very complex workflow. So different price point there, but you can build a simulation model that a lot of people can use, and you can use it for a long time. And we can definitely help, either train you to build those simulation models or really, take the work on ourselves. But you can see here, these two models that I showed you today, fairly straightforward, fairly easy to build for us, and, after a little bit of training for you as well. Anything else? All right, so I will be posting the recording of this. I will send out that link to you guys, probably post it on LinkedIn as well, and email it to you directly. Thank you for joining me. I'm going to do more of these in the future, either through instructional sessions or just kind of displaying simulation models that we have. One thing to look out for is we do have a presentation at Tailings and Mine Waste. I think, I'm presenting on a simulation model that we created for a tailing storage facility, and really leveraging stochastic data in this case. And I think my boss, Carlo Cooper, is going to be presenting a paper as well that, we worked with a client on another simulation model. And I think we have a bunch in the pipeline that'll be very interesting. So yeah, if you're curious, if you have a workflow or you have a project and you're, curious as to, is this something I could automate? How much of the detail, in my day-to-day can I actually incorporate it into these models? Can this save me some time? Please reach out. You can take a look at the project, see what would be involved in it. And otherwise, more generally, if you want a great Earthworks software that's fairly streamlined with a lot of powerful structure building tools that could save you some time, I think Formation is a good option. All right. Well, thank you, and have a nice day.